A CCD semiconductor is the image sensor in a digital camera or camcorder. When you snap the shutter, you expose the CCD to patterns of light. It records them electronically by converting them into millions of electrical charges. The camera's processor then reads these charges and translates them into the image you photographed. CCDs, or charge-coupled devices, are made of silicon, the main element in sand. What's special about silicon? When light hits it, you get electrons. Production begins with a round silicon wafer 15 centimeters wide and about as thick as a shirt cardboard. It goes into a steam oven for 3 to 4 hours. The intense heat, along with the oxygen and hydrogen gases in the steam, create a glass-like layer on the wafer. This insulates the silicon against the miniature electrical circuitry they'll build onto it. But before making that circuitry, they cover the wafer in conductive material. This conductive layer measures less than a micron. A human hair is 100 times thicker. Onto that, a robot applies a 1-micron thick layer of photosensitive resin. When exposed to light, the resin will undergo a chemical reaction. A technician suspends a mask over the wafer. The pattern on this mask is the schematic for part of the circuitry. When you take a picture, you expose the silicon wafer to light, and that generates electrons. The circuitry carries those electrons to the camera's processor, which reads the charges and translates them into an image. This machine exposes the masked wafer to ultraviolet light. The resin shielded by the lines of the circuitry pattern remains intact, protecting the conductive layer beneath it. The resin on the areas not masked by the circuitry pattern breaks down and becomes vulnerable to specific chemicals. The next step is to spray the wafer with those chemicals. This dissolves the resin, exposing the conductive layer underneath. Technicians repeat this entire process with anywhere from 13 to 30 masks until they've built up the full circuitry pattern on the wafer. Next, technicians submerge the wafer in acid, which eats away the uncovered conductive layer. So now, the only conductive material left on the wafer is the actual circuitry, the unexposed resin coating having shielded it from the acid. Next step, a thorough rinsing in ordinary tap water to remove the residue. Then a rinse with purified water to remove any impurities left by the tap water. Throughout production, contamination is a concern. Just a single speck of dust can ruin a wafer. To protect and insulate the circuitry, they coat the wafer in liquid glass, then bake it for 2 hours until the glass solidifies. The wafer surface is divided into 25 million tiny square cells called pixels. When you take a photo, each pixel records the light intensity of a minute portion of the scene, generating an electrical charge. A filter on the CCD translates each pixel charge into color. The company makes this filter with 3 pigment powders: red, green, and blue. These 3 colors combined can reproduce any color. The camera's processor reads and then reconstructs the photographed scene pixel by pixel. Each finished CCD undergoes a battery of automated tests to ensure that all the circuits are functional. This machine marks faulty circuits with ink. Just one bad circuit is enough to discard the entire CCD. Technicians then check every CCD under a microscope, looking for scratches that might have occurred during the production process. This CCD with 25 million pixels is called a 25 megapixel CCD. The number of pixels on a CCD varies depending on what type of camera it's for. This company even produces a single CCD that has 111 megapixels. So, the next time you say cheese, remember that you're producing a digital photo thanks to all that painstaking work that went into the sophisticated CCD semiconductor inside your camera.